Okay, so we're going to do 86 right now because this is just going to take too much time. So algebraically determine the intersection points of the graph in the system. How many times do the graph intersect? Okay, so I'm going to sketch both of these on my graphing calculator. Again, if you don't have this at home, sometimes it does help to have technology. So we have y equals 4x minus 7, and then we have x squared minus 2x plus 2. So I'm going to graph both of these, and I should probably change my window in a second. Okay, yeah. Zoom, go to standard. Okay, there's a line. There's a parabola. Okay, so it actually does hit the parabola, and it looks like it only hits the parabola one time, if I'm not mistaken. So let's zoom in. See what happens. Let's go maybe somewhere over here. And see what's going on. There's a line. Ooh, there's a parabola. Okay, so it looks like it hits it one time. Technically, it's probably twice, but we're probably only going to get one answer. So, yeah, so it does hit it, so that's good. Because if it didn't hit it, I would just say, okay, it doesn't intersect and move on. So, let's get cracking. Alright, so first thing is put them equal to each other. So we have 4x minus 7, the linear function, is going to be equal to x squared minus 2x plus 2. And the question is where? That's really what you're trying to find right now. We're using equal values method to figure out, okay, well, when they're equal to each other, that means they must hit each other at that point. So x squared is here. I'm going to subtract the 4x to both sides. So we have negative 7 equals x squared minus 6x plus 2. Add a 7. Wow, I don't know what that was. Add a 7. So we get 0 equals x squared minus 6x plus 9. Okay, so from here you have a choice. You can factor, which means the box and the diamond. Or you can do quadratic formula. Or you can do complete the square. I don't care which one you do. You just should be able to tell me how to solve this problem using any of those three methods that I mentioned. Myself, it would be me myself. I like to factor all the time. So if I can, so I'm going to try to factor x squared positive 9. Some numbers that'll multiply to 9 but add up to negative 6. That's going to be negative 3 and negative 3. So now I know I have negative 3, and then minus 3, and lo and behold, I get x minus 3 and x minus 3, and I think I was right. I have two of them. Okay, so 0 equals x minus 3 squared. So if I take the square root of both sides, the square root of 0 is still 0, as far as I know. No math has changed there. So I have x minus 3. Technically, there's still two answers. It's just now I know 0 equals x minus 3. So I only really have one to work with. So 3 is equal to x. So at the point where we were graphing it, where x was equal to 3, which is actually, I don't know if you can see, sorry. Where x was equal to 3, which was over here, and going up, that's where it actually hit on the x-axis. The only question is, what was the y-coordinate? So we're going to have to take the x equals 3 and plug it back in. I actually don't care which one you plug it into, as long as you do the work correctly. Considering that we've got a quadratic in here, and this one seems a little easier, I'm going to plug it into the line, because it should still give me the same answer. 4 times 3 minus 7, so I get y equals 12 minus 7, so I have y equals 5. All right, done. So now I know if I graph the parabola and the line, I should have an intersection of the two functions happening at 3, 5. And that is the final answer. Then sketch a graph of both functions to confirm your solution. Okay, well, here you go. If you want, I can zoom out for you really quickly. There's the graph. There's that one. I think I want to zoom in really quick. Let's zoom in like somewhere here. Oh, that's better. No, it's not. That was a bad one. Dang it. Window, nope, zoom, 6, enter. Well, you get the point. I should probably just restrict my windows. And I froze my calculator. Awesome. Okay, moving on. 88 is the next one. So for the quadratic functions below, complete the square to write it in graphing form. Then state the vertex of each parabola. Okay, I'm not doing this one because that one you should be okay with. You might have, wait, is this a subtraction? Okay, fine. We'll do this one and see what happens. No, it should be okay. Okay, so we're going to complete the square. So we have x squared. Half of 4 is 2x, 2x. That means we're going to need to add, so 0 equals x squared plus 4x plus 5. So that means we have a 4. And we really have a 5. So we're going to need to subtract 1, subtract 1. Okay. That'll give you the 4 that you need at least, right? 4 minus 1 is, 5 minus 1 is, so negative 1 equals x squared plus 4x plus 4. Alright, so negative 1 equals x plus 2, because that's x and that's 2, that's x, that's 2. So negative 1 equals x plus 2 squared. And I'm going to add 1 to the other side. So now I have x plus 2 squared plus 1. Okay, now I know I went really fast, but you guys should be able to follow this by now. So your vertex is going to be at, it's positive 2, so it's negative 2 and then plus 1, so just negative 2 and 1. And if I were to graph this right now, the way that it looks, from the original, the y-intercept was the number on the end because it's in standard form, so I can just take the positive 5, so I know it hits it at 5. And the vertex is at negative 2 and then positive 1. So negative 2 and 1 right here. So this parabola is going to go in this direction. And there it's at. And there it is, I should say. That was bad grammar. And then state the vertex of each parabola. Well, you didn't need to graph it, but I'm graphing it so you see what it looks like when you actually do graph it. Okay, you need to do B on your own. All right, 89. I'm already at 7 minutes. The United States Department of Defense is located in a building called a Pentagon because it's in the shape of a regular pentagon. Okay, Pentagon was 5 sides, if you don't remember that. Known as the largest office building in the world, exterior angles measure 921 feet. Okay, so what is the area of land enclosed by the outer walls of the Pentagon building? I'm super confused by this question because I would just say, just find the area of the Pentagon. So I guess just find the area of the Pentagon. So this is 5 sides, right? So 1, 2, I always forget how to draw Pentagon correctly. 1, 2, 3, 4, 1, 2, 1, 2, 3, 4. No, that's too many. I'm going to end up with a 6. Hey, all right. That's not bad. I did want to do it upside down, though. But you get the point. Okay, well, maybe there you go. Okay, so this is a 5-sided figure. There's a pentagon for you. And then the exterior edges measure 921 feet. That's the only thing I have to go on. So I'm assuming that the outer walls, which are these ones, measure 921 feet. Okay, but that should be enough. So, to recap finding the area of polygons, first of all, you need to tell me how many sides, which in this case would be 5. So 5 sides minus 2 times 180, that's 3 times 180. So what is that, 540, I think? I can't never do 5 times 3 times 180. I'm pretty sure it's 540. 3 times 180. Yes. Okay. So 540. So each of these, all of the angles inside add up to 540. Well, we have 5 angles and they're all the same because it's a regular building. So 540 divided by 5 gives you 108, right? And then in order to find the area, I need to find the area of at least one of these triangles in here. So I'm really looking for, so this was 108, and if I cut 108 in half, I should get, divided by 2 is 54. So this is 54 degrees, and what I really want to do is I need to find the height of this building. Of this part of this triangle. So I'm going to take this triangle right here, and I'm going to copy it over here. Okay, so this is 54 degrees. The whole bottom is 921 feet. But in order for me to even find the height, which is really what I want, let's call it the x, I need to know half of this so I can use trig to find it. So half of 921 is going to be 460.5, right? Yep, 460.5. So I want the height. I don't need to find the hypotenuse. There's no point. I don't need it. I really just want the base of the whole triangle is, I already know, 921. I just really need to find the height of the triangle. So I'm like, okay, well, this should be easy to do. This is opposite. This is adjacent. So opposite and adjacent is tangent. So tangent of 54 degrees, opposite is x, adjacent is 460.5. Tangent 54. Tangent 54. Okay, first of all, let me make sure I'm in mode of degree. Nope. Ah, see, I would have totally gotten that wrong. I didn't even check. Or at least it's a good thing I checked. I'm supposed to be in degree. So, let's try this again. Tangent of 54 is 1.337, 376, okay, let's draw 3764 equals x over 460.5. Put it over 1, so times 460.5. So that gives me the height, or x, is going to be 633.8239. So the height of this triangle is going to be 632, whatever. Okay, so the area of the triangle is going to be the base, which is 921, times the height, which is 633.8239, all divided by 2. Oh my god, I don't know why I just spazzed. There's a point right there. Okay, so times 921 divided by 2. So the area of this triangle, and by this triangle I mean the triangle that I'm about to highlight that's in orange. Triangle right here. So the area of this triangle is going to be equal to 291875.8942. And then area of the pentagon, which is really 5 of these, just multiply by 5 times 5, is going to be 1459379.471. Okay, there's a lot of numbers in there. So this was feet squared because we were doing the area, and I think that's correct. Let me check my key. Yes! All right. That is awesome. I got the right answer. I'm so excited. Okay, and then what is the area? If 1 mile is equal to 250 or 5,280 feet, what is the area in square miles? I'll let you figure that one out. I think it's somewhere around 0.05, 2, somewhere around there. So 0.05. If you get close to that one, you're okay. All right. I'm going to stop there for this one because there's just too much time on the clock now. So if you need more, I'm going to come back with 90 and 91.